Okay, so I'm so sorry. I still not sure why or how to turn on the comment sector. I'm so sorry lah because I really very bad in this YouTube thing. Then let me see what I can do in here. Mm, I'm also not sure what I can do. Uh, okay, so maybe I'll just leave it like this for time being until I learn on uh, how to leave the comments in here. So okay, whatever it is, time waits for no man. So without any hesitation, let's begin our lesson, shall we? So let's do it. Okay, so this is where we stopped yesterday. So yesterday we stopped at the objective question. So today we are going to continue with the essay question. So in here I shall teach you on the technique of how to answer essay question for organic chemistry. So sometimes the way of how to answer STPM organic chemistry can be quite tricky at times, and you need to understand on the way of how to explain things and the keyword that is usually used in the questions in order for you to answer well. So today we shall have a look in what are the types of the question that can be asked in STPM, and how are you going to elaborate the answers inside here. Okay, so without hesitation, let's have a look at question number one. So question number one sounds like this: 4-bromo 4-methyl hex 2-ene CH3 CH double bond CH CBr CH3 CH2 CH3 exhibit geometrical isomerism and optical isomerism. Number one, what do you understand by the terms geometrical isomerism and optical isomerism? So this first question is asked you to define what is the terms of geometrical isomerism and optical isomerism. So as for per definitions, how should you define geometrical isomerism and optical isomerism? So you should state that geometrical isomerisms are isomers that have the same molecular structure, okay, same molecular structure, but different arrangement in space. Same molecular structure, but different arrangement in space, okay? So this is a very important keywords to define on how to, this one, some books use different spatial arrangement, so whatever it is, they are the same, okay? Whereas optical isomerisms is defined as isomers that have the same molecular structure but different effect on plane polarized light. So that is how you should define in between geometrical isomerism and also optical isomerisms in here. So hopefully you'll be able to uh, hopefully you'll be able to understand better on how to define the isomerisms inside here. Okay, so number two, draw the structural and name the geometrical isomerism in 4-bromo 4-methyl hex 2-ene. So you have to understand from the structure in here. In STPM, usually they give you in the terms of condensed or partial condensed structure. So you have to learn how to open up the structure as in this one. So when you open up the structure, so it will look more or less like this. Okay, you open up the structure, it will become CH3, okay, C, H, and then you have double bond, CH, CBr, CH3, then you have CH2, CH3. So this is how the structure looks like after you open up the structure. So from here, you can see that this part of the carbons will exhibit geometrical isomerism because it has hydrogen and also CH3 behind here, which is two different groups of atom, whereas this carbon have these two different groups of atoms in here. Okay, so you must be very good in knowing on how to identify geometrical isomerisms. Okay, so you for that you draw the cis and trans molecules for 4-bromo 4-methyl hextluene, as in like this. So you draw CH3, this one. Now make sure that in between the bond must be connected to the carbons inside here. You must show clearly on the connections in between the carbon-carbon bond. It is wrong if you connect to the hydrogen. This is a wrong way to describe the structure. So you have to be very careful, especially when it comes to the isomerisms in here. You have specifically stated the bonds in here, whereas this one is automatically connects to this carbon. Okay, so with this is how you draw the structure, and from here you can see that this is a cis. This is a cis, not trans. I put reversely. Sorry. I put reversely. So this is a cis carbon. This is a cis isomer, whereas this is a trans isomer. So pardon me for my mistakes. Okay. This is a cis and trans isomers for in between the two. So you must be very good in determining the structure in here. Okay, so usually when they give you the full teacher, can I answer as cis isomer and trans isomer, not writing as cis 4-bromo like this? Now you must write, especially when the question already give you the full name of it, so you must write again the cis with the full name, and after you write the cis, don't forget a dash in here. Okay, then trans must also put a dash in here. Okay, so 4-bromo 4-methyl hextluene in here. So you must write exactly back the cis and trans in full name, especially when the question's already given to you the full naming for it. Okay, so this is the two isomer of how you should draw the structures in here. Okay, and finally draw the structure and explain the optical isomerism. Not only they want you to draw the structure, but also you want you to explain the optical. So how would the molecule exhibit an optical isomerism? What are the characteristics to exhibit an optical isomerism? You must have a chiral carbon atoms. You must explain like this. You must have a chiral carbon atoms surrounded by 4 different atoms or group of atoms. Chiral carbon atoms that is surrounded by 4 groups, 4 different atoms or different group of atoms in here. And then every time when you already identify this characteristic, always put an asterisk like what I showed you in here in order to find out. So no matter what, always put the asterisk to chiral carbon atoms. Okay, so you have to put the isomers and then put the chiral carbon atom, and then even in here you also mark with a star, okay, like asterisk like this, okay, to show that it is a chiral carbon atoms. So as a student, you don't bother where are the marks located. As a student, you should try your best to define as fully as you can. Has chiral carbon atom. Then if I were a student, I will further write surrounded by 4 different atoms. Okay, surrounded by 4 different atoms or group of atoms in here. Okay, so that is how you are going to explain geometrical optical isomerisms. So that is for question number 1A. Then we go to have a look at question 1B. 3-methyl 4-hexene 3-ol CH3 CH2C CH3OH CH double bond CH3 shows stereoisomerism, which is geometrical and optical. Describe the stereoisomerism present. So when the question asks you to describe, that means you have to describe what are the characteristics that give geometrical and also optical isomerisms in here. Okay, what are the characteristics that gives you geometrical and optical? So like I said earlier, as a student you shouldn't estimate where are the marks located, even though in here clearly says that this is 8 marks. So but if I were the students, I would definitely write as much as I can, including definition, what are the characteristics. So so that I wouldn't lose the marks inside here. Okay, okay, and then whenever you are given in a condensed formula like this, you must be able to expand the structure on your own. Okay, so how will you expand the structure? So the structure will more or less looks like this. It will become CH3, CH2, then you have C, CH3, OH, and then you have CH. Why would I want you to do like this, so that you can see clearly where can you exhibit geometrical and optical isomerism. So this is clearly surrounded by four different four different groups of atoms, whereas this one is obviously has geometrical isomerisms in here, isn't it? So sometimes when you read in the form of a condensed formula such as like this, it is very hard for you to identify the isomers that present in these molecules. So you better know on how to open up the structures on your own. Okay. So like I mentioned just now, you if possible, you define and then you describe what will be the characteristic. So and here it shows you the answer. So you must first mention that in a geometrical isomerism, double bond exists. This is for geometrical. This is for geometrical. For geometrical isomerism, a double bond exists in between the two carbon atoms, and each carbon is attached to two different atoms or group of atoms in the C double bond C in here. Okay, so because we are answering to this question, so we are defining based on this. But not only that, you can have a C double bond C that exhibit geometrical isomerism. Cycloalkane can also exhibit geometrical isomerisms. Okay, so and then after you describe, definitely you would like to draw out the cis and trans isomer. Okay, so you draw out CH3 CH like this. So you must make sure that it is drawn exactly at the carbon to carbon bond. Now if you are good in expanding the formula like I shows to you in here, you can choose to draw your structure like this, no problem. Okay, and then if possible, name, don't just cis and trans, label with full name. Cis 3 methyl, okay, 4 hexane 3O like this. Okay, this one also trans 3 methyl and so on. Okay, so write in the full names. Don't give cis and trans just like that. Don't, especially when the question already give you the full name for it. So I would advise you all to write with the full name for cis and trans isomer for both of them. Okay, so that is for the first one. And then for the second one, what about optical isomerism? So like I said just now, you would like to define first. So optical isomerisms are isomers with the same molecular structure but different effect on the plane polarized light. So it must have a chiral carbon atom, or you label with a star also can. Okay, and then which is surrounded by four different atoms or group of atoms, and the structure of isomers are not superimposable or cannot be overlapped. Okay, and then finally you draw out the pair of the optical isomerism in here. Okay, now when it comes to draw the optical isomers, one thing that I forgot to highlight just now, please do not use the structure. I see some of the books, they love to write the shortcut, like let's say like this CH3 like this, isn't it? They love to show the student as C3H5, for example. Okay, they like to put it as a C3H5 general formula. Actually cannot. Try your best not to put this general formula like this, because C3H5 can be many things. What happens if C3H5 looks like this? This is also C3H5. Okay, this is also C3H5, isn't it? So you get what I mean or not? So in here, you don't write the general formula like this, especially when the question already give you the structure of the molecule itself. If the question already puts such a purpose to give you the structure, so might as well you use the structure. Don't use a general formula like this. Okay, so it will cause you to lose marks in here. Okay, and unlike geometrical, optical isomerism don't have cis and trans pair. So the moment that you draw the pair of isomerism, then it should be this one. Now the trick of how to draw the cis trans pair, of course, this is not a very good way lah. I will usually advise students for complicated molecule you draw above and below, and then you draw accordingly. And then one more is this dotted line important or not? For me, actually, for STPM students, actually, it's not extremely important to draw dotted lines such as like this, dotted line, bold line such as like this. But if you are able to draw, so why not? Okay, so just draw lah. Try your best to draw as good as you can. And then, can we put like this or not? Let's say A, B, C, D lah. Let's say, can we put like this or not? Let's say, for example, advisably don't put like this, okay, because it doesn't shows the three-dimensional array of this structure. Because the most important key in here is when it reflect, not only that it reflect in terms of the molecule, but also in terms of the structure itself. You see, this one is it is slanted to the right, isn't it? But then this one is slanted to the left, isn't it? So the way of how you express your dimensional must also be three-dimensional structures in here. Okay, so it is not advisable for you to draw your structure looking like this. Please do not draw like cross like this lah. Okay, try to like this, like this, like this, and like this a bit. Okay, so at least like this is okay. Okay, at least like this is okay. Okay, so that is the tactic lah of how to answer essay question for question number 1. Okay. Okay, so any questions later you can private message me later. Okay, then number 2, trifluoromethane. Trichlorofluoromethane, CFCl3 or Freon 11, was introduced in 1930s to be used in foam insulation, cleaning, sterilization, refrigeration, and other industries. Using the concept of hybridization and overlapping of orbital, describe the formation of bond in CFCl3 and draw a label diagram for this molecule. 6 marks in here. Okay, for drawing the hybridizations structure, this one, usually I will advise students to draw as fully as you can, including what, including you like to start off from we said that ground state, okay, ground state, for example, okay, you start from like this, you draw the energy level. Essay you spend a little bit more time to answer is okay, because it is essay. You are supposed to write as much as you know, isn't it? Okay, and then excited state, okay, then hybridized state, etc., etc. Okay. So I usually advise students to draw accordingly like this, okay? And then when you draw the orbital overlapping diagram, you draw nicely like this, okay? And then you draw lah, how does the carbon overlap in tetrahedral lah, and all this and that. So it is always, as I told you, don't predict where are the marks located. As a student, you should write everything that you know in here, okay? So you start like this, okay? Then because the questions wants you to describe the formation, okay? So you need to explain. So this carbon is sp3 hybridized, okay? So inside here, where the p orbitals of the fluorine, okay, p orbital overlap. Okay, then if this is I use different color so you can. So yeah, okay, I use different colors so that you can see what is going on in here. Okay, so if then you put this is a chlorine, okay, Cl. You put this a chlorine Cl. This okay, fluorine Cl. Okay. And then you even draw the pair of electrons in here, okay, like this. Then you even put that this is a sigma bond. Label everything that you know, okay. And then what is the angle? Okay, 109.5. Okay, what is the type of hybridization? sp3 hybrid. So put all possible way to this one. Okay. Okay. So once you are able to describe all this, tells you, you'll be able to definitely score as much as you can for such type of marks in here. See, because the questions also wants you to describe, so you better write some words inside here, lah. So this is how you are going to get the marks in here. You must say that C is sp3 hybridized, Cl and F use p orbital or to overlap between the CCl and CF bond, where the shape is tetrahedral, where the sigma bond. So sigma in here you can also label, no problem. Okay, once you do like this is already a full marks of how to explain the hybridization. And as I told you, don't bother whether ground state, excited state, hybridized state has marks or not. That is not up to you to decide where are the marks located. As a student, you should describe as fully as you can for the way of how you are going to draw the structures in here. Okay. Okay, so that is how you're going to solve for the answer for involving hybridization technique. So try your best to describe as fully as you can. Okay, okay. Then we are going to have a look at 2B. Two compound A and B are hydrocarbon with the empirical formula CH2. So this is the empirical formula CH2. When you have the description question like this, try your best to highlight as much keyword as you can inside here. So S has 1 pi electron, okay, while T contains only sigma bond. When 0.1 mole of A and B are burned, they form 0.60 mole of carbon dioxide and 0.60 mole of water. Draw the structural formula of A and B. Explain in terms of bonding of A and B and their molecular shapes in here. This is obviously a very direct question that tries to tell you that what is the number of carbons inside both A and B. Okay, so let's start off first with the empirical formula. You see in here, empirical formula is CH2. The moment that you see empirical formula with the CH2, there is only two structures that you can come across easily. One is definitely an alkene, and another one is definitely a cycloalkane. This is the only two that have the general formula, empirical formula of CH2. Okay, and then when the questions already give you 0.6, so since you write since CH2 power of n, okay, when burned with oxygen, okay, will produce CO2 and H2O. So this one 0.1 mole, okay, this one 0.6, this one 0.6. So the ratio in here will be 1 to 6 to 6, okay. So therefore, C in here is equals to 6. So H over 2 is equals to 6. So H is equals to 12. So you describe as fully as you can. So the structure is C6H12. So when C6H12, you can put any structure that you want. Okay, hex 1 in, hex 2 in, hex 3 in also can, then cyclohexene also can. Okay, so you draw. So you have to first deduce the molecular formula of A and B is CH2, and then C6H12, and then you deduce the structure of A and B. So as long as the isomer contains 6 carbon, so any isomers are accepted, and then B is also cycloalkane, and as long as you have 6 carbon, any type of cycloalkane can also be accepted. So it's up to you, but usually students will put it as simple as you can, unless there are description that says that cannot be like this. Okay. Okay, then explain the bonding. So the question also wants you to explain the bondings inside the A and B. So you must say that contain one C double bond C. Okay, so therefore you contain one pi bond and one sigma bond. Okay, whereas in cycloalkane, because it is so you describe even this is an unsaturated hydrocarbon. Okay, this is a saturated hydrocarbon because it contains only sigma bond, okay, etc., etc. Okay, so you try your best to describe as fully as you can for how to answer the A and B in here. Okay, so you have to mention carbon in A is sp2 hybridized. Okay, so this one is sp2 hybrid, whereas all the carbon inside the B in here is sp3 hybrid. Okay, so if they also want the molecular shapes. So in A, it has a trigonal planar shape. In B, it's a tetragonal. Since A has a pi bond, so they form double bond in between C single bond C. And then uh, until the extent, you have to also compare in the bond length in CC. So the bond length in the C double bond C is A is shorter than the C single bond C is B. Okay, so until that extent, you have to try your best to explain as much as you can for essay question for organic like this. So that's why I said organic sometimes can be very tricky, because the greater the marks, the more things that you have to explain. So if I were a student, I would even put the angles until the extent of angle. This is 120 degree, okay, and then this one is 109.5, okay, for example, like this. Okay, and then label all the pi bond, sigma bond, whatever that you know on how to write. Okay, so you must plan your essay questions nicely. Okay, and then write as much information as you can for the way of how to answer these essay questions in here. Okay, okay, so for now, that is how you are going to answer for organic chemistry question. So I hope that in future, whenever we discuss essay question, I'll be able to expose to you more and more technique of how to answer STPM questions, especially when it comes to essay. Because one of the most difficult part for STPM students is to answer the essay for organic chemistry, because it requires a lot of technique, correct technique to answer in here. Okay, so I guess that is all for the chapter 1 that I want to share with you today. So tomorrow we shall continue with the chapter 2. So you better try your best to finish all the objective, structure, and essay question. We will discuss as much as we can. Okay, so for chapter 1 it will be a little short, and then for chapter 2 onward it will be 30 structure, 30 objective, 6 structure, and 4 essay. So all of them we shall discuss. Okay, so I guess that is all for our lesson today. So I see you on our next lesson tomorrow at the same time. Okay, see you around. Goodbye.